Hello, Professor. My name is Vincent Fernandez, and my second video is going to be on F2. Let's see the name for it. F2 graphs of equations in two variables, intercepts, and symmetry. Alright, bam. Today's day is the 19th, I believe. Maybe it's the 20th. I'm not sure, honestly. Okay, let's do this. So let us start off with number 1 from the homework. So the question I am given is, when it loads, let's see. The equation that I'm given is y is going to be equal to x to the second minus square root of x. And the points that I am given are 1, 0, 1, 0, 0, -2, 2, -1. So now to do this, I'm going to have to spread this out just a little bit. 0, -2, 2, -1. Alright, so to do this, all you have to simply do is plug in each of them into the equation. I'm just labeling them x and y so I don't get confused. So let's plug it in. So 0 is going to be equal to 1 to the second minus square root of 1. So let's see if this works out. So 0 is going to be equal to, what's 1 times 1 is 1, minus 1, which is square root of 1, which is 1. So 1 minus 1 is equal to 0. So it looks like 1, 0 works out fine. So now, number 2, 0, -2. Well, let me make that straight for you, sorry. I was probably blocking all of that. So 0, -2. Let's plug it in. So we have the y as -2. It's going to be equal to 0 to the second minus square root 0. So we're bring that down. 0 to the second is obviously still 0 minus, there's no square root of 0, which is still 0. So that one does not work. And let's go to the third and last one. Let's plug it in. So -1 is going to be equal to 2 to the second minus square root of 2. We have -1 over here. 2 to the second is going to be 4 minus, which is still the square root of 2. And we just can't really do much with that anymore. We can't simplify that any further. So 4 minus the square root of 2, to the square root, obviously does not equal -1. Okay, now let's continue on. Okay, let's pull from here. Alright, I'm gonna bring you over here to my laptop just to show. It's asking here to plot the point, then plot the point that is symmetric to it with respect to the x-axis, y-axis, and origin. So this is just so that you know that I know how to plot things in regards to the origin and the x-axis and the y-axis. So let's first go to 3, -4. Alright, good. Now next one is going to ask me to do to respect to the x-axis. So that means that I need to do this, the mirror version of it, to the x-axis. So that would mean that it would become right here. Bam. It would become +3 and +4. Okay, now to respect to the y-axis, that means I need to do it to the mirror side to the left of it, over the y-axis, which would be right here. Nope. Right there. Nope. Which one is it? Bam. Right there. Okay, and then to the origin now would mean that I have to make these both into negative numbers. Since that one's already negative, that means I'm going to across. So across the x and y plane. So that would make me go right around. What is that? So I'd make -3 and +4. Go bam. There we go. Now, let's get back to this. let's go down to, let's see here. Not that one, but let's go down to number, let's see, 14. No, 15. Let's make number 15 the one. Okay. Oops. Can we see? It's good for you? Good. Okay, so number 15. Number 15 now we have right here is going to be y to the second is going to be equal to x plus 4. So what we want to do is we want to find the intercepts, which means that we need to make y 0 and x 0. So first we're going to put y is going to be equal to 0. So 0 is going to be equal to x plus 4. We're going to do minus 4. We're going to cross that out. And then we're going to bring it over here to the side. So we have negative 4 is going to be equal to x, which we're going to convert into an ordered pair, negative 4, comma 0. So next we're going to make x 0. So we're going to keep the y to the second, make that equal to 0 plus 4. We're going to do y to the second is equal to 4. We're going to square root it. Y is equal to 2. Not just 2 though, but plus and minus 2. So we got that there. So now we have two ordered pairs though. So we have 0, comma negative 2. And we have 0, comma positive 2. And so now it's asking though if this will be well, the question on the Pearson website is asking if this would be symmetric to respect to the x-axis. So we need to remember the x-axis symmetry will make the x stay. Oh, is that in the way at all? There we go. That's better. It make the x stay where it is, stay positive, but it will change the y to become negative. Y-axis symmetry will allow the y to stay there. Will allow the y to stay positive, but it will change the x to become negative. The origin, that will change both the x and the y and change them both into negative. So what we see here, we can use our 3 points as our test subjects. So what we see here very clearly is that there's a 0, comma negative 2 and a 0, comma 2. What does that look like? That looks like x-axis symmetry, where not only will there be a point where it's positive on the y, but also negative on the y. So I would say that the x-axis symmetry is actually the ticket for it. Y-axis symmetry, I do not believe though. And origin as well, that they just would not work because you will not have points where there's a negative x, y, and a positive xy that are the same points. And the same goes for origins. So for that reason, the x-axis symmetry would be the one to go with, and not the y-axis symmetry or the origin symmetry. Okay, and last one. Let me see, where do I go? Okay. So on the screen, it's asking to find the intercepts for this graph right here. So it's asking me to find the intercepts, and what we can see here is that we have a negative 3, comma 0. We have a 4. We have a 0, comma 4, and then another 3, comma 0. So let me put that into the computer real quick. Give me 1 second. And there we go. And there's only one part remaining. And so it's asking if is the graph symmetric to the respective x-axis, y-axis, or origin, and we can see very clearly, get out of here. And we can see very clearly that it's a mirror onto the y-axis, meaning that it is the graph is symmetric with respect to the y axis.